Hi, my name is AJ Ballin, and our group is doing chemistry of candy. And this is my partner.
Hi, my name is Alexander, and I'm going to teach you the chemistry of candy. So here's our candy here. There's a candy, we're going to explain what this candy is, and today I'm going to make a very special treat. I'm going to make pralines. Everybody already knows what a praline is, but not many people have seen how it's made. A praline is a very delicious treat. It's basically a bunch of sugars heated and mixed together with pecans in it. And I'm going to show you just how to do that. So when people talk about candy and sugar, they usually think about crystallization. Well, it's actually very interesting. If you see here, I have 3 things I'd like to show you. Crystallized brown sugar, Jolly Ranchers, and Hershey's chocolate. So if we were to talk about something like crystallization, let's talk about the word crystalline. A crystalline sugar or mixture is actually has low sugar concentration. It boils at a lower temperature and contains small fine crystals of sucrose or sugar. Okay? And there's also non-crystalline. Those have high sugars, high boil temperatures, and they're made from a saturated solution of fructose and glucose. So let's start with our chocolate here. Notice our chocolate. This is a crystalline candy, but it's not crystallized, it's crystalline. So everyone has eaten chocolate before, and if you haven't, well, they're very smooth. It's actually very smooth and creamy, and well, their sucrose molecules are able to align and form large, what are we looking for? Lattices, sorry. But our Jolly Ranchers, on the other hand, these are generally hard and brittle, and these are formed when crystallization is actually prevented. This can be accomplished by the addition of sugars such as glucose and fructose that interfere with the development of crystals. Often, their mixtures are too viscous for crystals to form, and this is actually a crystal. This is the natural crystallization of basically an unnatural sugar. So right now I'm going to give you guys an example of melted sugar, and I'm going to explain the cold drop test. See, back in the day, people here in New Orleans, when they made candy, they didn't know exactly what temperature to get it at, because nowadays we have things like electric candy thermometers like sugar thermometers that measure how hot a sugar is, or how hot their fire and sugar is. So I'm going to melt the sugar down, and I'm going to demonstrate a cold drop test side by side to something like corn syrup. So I just melted down some sugar, just some regular sugar, and notice the color that it takes. So there was extra things in here, but that's not really needed to know. What you need to know is this is melted down, and I'm going to show you exactly how people used to do the cold drop test. So the cold drop test works like this. You take a little bit of sugar, you bring it over a bowl or a cup of cold water, and watch what happens when you put it into the water. Now, if you notice, this sugar immediately got hard. Now this is corn syrup. This is a different type of sugar. So, watch what happens when I put my finger in the corn syrup. See that? It just basically dissolves. I can't do much with it. It's been processed. And if I stir it a little bit, it mixes in with the water. My sugar, on the other hand, notice what happens. I can break it up and still dissolve it, but I can pick it up. I can pick it up and it has shapes. This one is in the shape of a leg, but this is the sugar. Now, if I were to cook this longer, I can make it something similar to corn syrup, but I'll be able to pick it back up and squeeze it between my fingers. And that's how I know I made a praline. Okay, so if you notice, I have my white sugar and I'm currently adding my brown sugar. Notice how I packed the sugar together. What this is going to do, it's still going to break down, but when I actually start breaking it down into the sugar, I get a different measurement. Because of the way I pack together the sugar, it's going to dissolve differently. There's going to be more sugar basically packed together inside of another type of sugar. Now that we have all of our ingredients here, we're going to start heating this up and we're going to start making our pralines. So it's really easy and it's really simple. But if we're talking about the chemistry of it, we need to note the temperature. Temperature is very important. When you do cook, cooking is more or less a sort of chemistry on its own. Temperature affects certain molecules, and these molecules, what happens when they start getting heated up, they start shaking. Everything's already always shaking, but heat makes things shake even faster and faster. And this constant shaking can break apart certain bonds. And sometimes the strength of the bonds depends on how fast they break or how high of a temperature you need for them to break. In our case, sugar, you don't need a lot. Sugar has like a weak link, so you don't need a lot of heat for it to break and break down. But what we're gonna do is heat all this up. We're gonna make all these sugars molecules break. If you notice already that they're breaking apart and they're turning from a solid to a liquid. Once everything here melts down to a complete liquid, we're going to mix them up and they're going to dissolve into each other. When they dissolve into each other, then we let them cook for a certain amount of time. Then we can start checking to see if they're ready. So if you notice the color of the sugar, it's very brown. This is called caramelization. This is the oxidization of sugar. This happens when volatile chemicals are released, and that produces like a caramel-like flavor and turns these sweet sugars brown. But this involves the removal of water. So the water in the sugar and the milk and the butter are all escaping. They're becoming steamed. And this happens around 320 degrees Fahrenheit, and it actually starts caramelizing at 230 degrees Fahrenheit. But this is basically how it starts. So believe it or not, the better tasting pralines have one special ingredient in it, and that's rum. Rum contains alcohol. So alcohol provides a very distinct flavor to pralines and make them taste a little special. So if I were to add alcohol to this mixture, this would be the time to do so. And it would actually take me about 15 minutes to cook all of the alcohol out and only leave the flavor of the alcohol. So now it's been a few minutes, and I'm going to show you exactly what I talked about earlier with the softball test. With the water drop test. And we're going to show you that this sugar is in the softball stage. So if you notice, I lifted it out of the water, out of the mixture, just a little bit of it. I'm letting it cool for a second in the air. I'm going to drop it into the water. Now, notice something. In the softball test, in the softball stage, it's forming these little balls around, and I can manipulate it. I can manipulate it in the water, and as you can see, it'll dissolve if I stir it really hard, but it's forming a little bit of a ball that I can actually lift out of the water with my fingers, press, and manipulate in any way I want. This is the softball stage of sugar. I've broken down the bonds to a certain stage, and now they're forming something of a solid. It's pretty cool, actually. So, after everything is said and done, this, it's not a praline yet, but this is a praline. It is hot and fresh out of the pot, and it's going to cool off and give off that distinct, delicious, rich brown color that everyone knows